This is Daniel. So welcome, thank you for joining us. Today we're going to be looking at programming live tool lathes / mill turns, multitaskers, whatever you kind of want to call them. So today we're going to look at kind of some typical kind of issues that people tend to face, differences between the setup between, say, for instance, a single spindle machine versus a dual spindle machine, some kind of common issues where people tend to get mixed up or confused about how it should be set up for both types of equipment. So if you're running like a Haas ST20 versus a DS30 SSY type machine, how you set the features up and how you do the programming for both of them. We'll also look at some of the difference between using XC moves and XY moves in programming and how you differentiate between those two in the software. And we'll take a look at polar coordinates and essentially the differences in the output and the code, what's going to go on the machine side of things, and look at some kind of typical sub-spindle transfer sort of situations so you can get an idea of how basically how you can set up the transfers, program them, adding an extra code that you might need to turn certain functions on and off and things like that. So we're going to look at this free hub example here. So we're going to use this particular portion of a wheel hub, basically. I made it just as a good example part. It's got some wrap features on it. It's got some turning, boring features in it on both sides. It's got some milling features on there as well, for the face milling side of things as well. So, but the key thing to start with is we're going to look at the differentiation between, okay, well, I'm programmed for a single spindle machine versus a dual spindle machine. If I have to manually flip the part around because I've got features on both sides of it, and like in this case here, we've got a bore on the left-hand side for a bearing and a bore on the right-hand side for a bearing and a threaded portion here. So how do we set the part up to be able to double chuck it on a single machine, or how do we do it to program it for a dual spindle machine? And if you take a look at the interfaces there, the two pictures of the interfaces, this is using the 2018 CAMWorks 2018 interface. So there's actually been some little changes, some subtle changes in there. We now have a coordinate system item in the feature tree where you can actually set, this is the main spindle coordinate system, this is the sub-spindle coordinate system, and you can turn them on and off as well now. So, so the red arrow is basically showing you the difference. Hey, I'm going to set it up for my main spindle, I'm going to set it up for my main and my sub-spindle. Then the blue arrows are showing you the difference, and this is where it really is important to understand how should I be setting it up if I do have to double chuck it. If I do that, then I have to have two turn setups in here. So the first turn setup is for my first setup in the machine. I'm doing, say, the right hand side of the part here, and then I manually flip it over in the machine, and then I basically do a same setup on the main spindle again, but I have two separate turn setups. So you can see the green feature, the green arrow basically is pointing to the ID feature for the bearing on the back on the left-hand side there. When we look at a dual spindle setup, when we're talking main and sub-spindles, we have one turn setup. So you'll see the blue arrow on the right-hand side is pointing to just a single turn setup. There's not multiple different turn setups in there. But the features inside of them will have the settings to control whether it's on the main or on the sub. And you'll see I have the same ID feature, but it's all included in the one turn setup. So let's have a look at that and how we basically understand and set those up for the different methods and where we can control all those information. So I'm just going to switch over to SolidWorks here, bring up my part right here. So I'm using CAMWorks 2018, like I said. You'll see some subtle differences if you're using 2017. But essentially, we go into our machine to start with here. And what we're going to do is, this is where we can check on and off the sub-spindle option. So when I uncheck the sub-spindle on the machine node here, use sub-spindle, it will basically set this to disappear. So the sub-spindle item in the tree will disappear. Your graphics view of the sub-spindle over here will now also disappear as well. So we can just focus on, okay, I'm just seeing the correct spindle here. So in this case, we're going to set it up for a single spindle. I've been through and I've added some material to my stock already on this side. And then basically we can run the extract machinable features. And what it's going to do is basically find the features and basically put in our features in there, but it's only typically going to put in the main spindle features for one side. Everything's going to be from one side, basically. So in this case, we've got a face feature. It's coming off the front here because this is the smallest end. If we were on the back side over here, we'd have to, as the first setup, we would have to flip the coordinate systems around and basically go and change it over here. But looking through the features here, we've got the face feature, the OD feature here, we've got a groove, and then we've got an ID feature here coming through all the way down here, which obviously we might not want to do. And we've got a cutoff feature, which in this case, we're going to actually face it. So we delete the cutoff, and then I add a new turn setup in here. So I right click on the stock manager, insert a new turn setup. In this case, we want our coordinate system reversed, so that our main spindle second chucking, basically the second setup is going to be from this direction. So now I have two turn setups. If I just kind of shift the order a little bit, you'll see I've got an ID feature on that side for the first setup, but I also need an ID feature on the second setup. So I can actually just drag this ID feature down. I'm just using a control key on the keyboard to copy it to create my second setup basically for that. And I will also go in and create new turn features for my face feature on the back in here. And basically we can adjust our order. And then our milling is obviously being also done on the main spindle. So we're going to basically just generate the operation plan, and we'll look at the program zeros, and you'll see some differences actually between 2017 and 2018, some really nice updates that they've done for us. So let's just adjust the order here. We've got our first turn setup here. So this is basically our first turn setup. We're doing all of our roughing, OD work, and things like that. And then we've got our second turn setup, which basically we can adjust to here. So now we can adjust in our program zero location. And this is some of the updates, the really nice updates from 2018. I can now, in Lathes, switch between basically a stock vertex. So I can either use a stock vertex for doing the programming, so I can shift it to the, if I'm touching off there, or probably more commonly the part vertex here. So I can actually just shift it to the face of the part right here and move it around. So now my program zero is right here. It's obviously going to want me to update since I've just shifted it forward. But you'll also notice this is pretty important for the mill part setup here. When we're looking at single spindles, we need to be sure which side the milling is on. So obviously we've got two turn setups in here. This is my first turn setup. This is my second turn setup, which is obviously this way. But my milling is thinking it's on the other first turn setup, which in this case would be on our second setup in this case. So what I have to do is make sure in my mill part setup down here that I go and adjust it to use that second turn setup, and it will flip the turret, or the spindle around to the correct orientation. So that's basically set up for double chucking, single spindle, double chucking the part, manually flipping it over. But what happens if we have to use a dual spindle? We've got the dual spindles, we want to basically use them and maximize the machine as much as possible. How do we set the part up for doing that? Well, I'm just going to create a new configuration here, just so we can start from scratch. We'll go in and select our machine. And in this case, we're going to use our dual spindle. So I'm not going to use, not going to turn off this use sub-spindle. We want to use it. This one up here will actually tell you if your post supports using it. There's a post variable in your post processors which will allow you to output the sub-spindle code or not. So if this is unchecked, you'd have to contact your reseller, us basically, to get that post updated. So we've got our machine set up, we've got our part, our stock material in here. We'll just add some material to all the sides here. Maybe if we're going to treat it as if we've got a big slug in there, so we get our truck clamping down on a decent area. I'll show you the coordinate system options now that you have in here as well. So the main spindle, basically, we've now got control. You can either use a stock vertex as well. So you can either say, hey, I'm using the back portion of the stock over here. You just click on the red dot and it will move around. Or you can use the part vertex and click on the dot as well at the relevant point. So in this case, we're going to basically treat it as the same sort of setup. We're going to go off the front face here. So that's my main spindle, and my sub-spindle here is automatically at that other side now as well. So I'm going to basically use that back face there as my sub-spindle origin point. And I'm going to extract the machinable features again, and now you'll see the difference between the setup when we use the dual spindle and programming for dual spindle. So we'll just let it find the features here. Same sort of procedure, same sort of setup that it first found when we did the main and sub. But what we now have the ability to do is basically in here, we just want to copy the ID feature and we'll convert the cutoff feature to a face feature on the, actually, since we added some stock, we'll leave it as the cutoff feature. But the ID feature here, what we can do is we're going to need to do two separate ID profiles. One's going to come in and rough from the right hand side on the main spindle, and then the other is going to come in from the left hand side on the sub spindle. We can just use our control key and control and drag it in here. But the key thing is to differentiate between main and sub. We have to tell it in the feature itself that it's on the sub spindle, and this is how the software knows which feature is on the main and which is on the sub. So typically it's going to find everything on the main, and then you go through the list and say, hey, I want to do this on the sub. You go through the OD feature, you can go on the sub. If it's set to both, you can program from either the main or the sub. So the same geometry can be used on either the main or the sub. And you can add operations appropriately to different setups. But in this case, I'm going to leave my OD profile set to the main feature. But this is essentially the correct setup for the turning. The milling side of it, because it's on the back side of the part over here, we're going to have to do that on the sub spindle. So all of these are going to be on the sub, basically. So we go through sub, and then sub spindle. And then we can hit our generate operation plan, and that is basically going to go through and generate our appropriate setups, if you will. So you'll see there's a difference in the operation trees, and the key difference to understand when you're doing main and sub work is anytime you're on the sub spindle, you will see a sub in next to the turn setup or the mill setup. So this is basically dictating that it's always on the sub in this case in here. So we have our turn setup. We've got our face, our OD, our groove, and boring, and then we've got a cutoff in here. But at the moment, we don't have any information about the transfers. Now, we'll get to that in a little bit. But what we're going to do here is if we just look at generating this toolpath here, you'll see actually our mill part setup here still thinks it's on the main. So I'm just going to actually put this to the sub spindle here, and it should basically now generate the toolpath in the correct orientation. But unfortunately, it doesn't know, like I said, that it's on the main or the sub. So this toolpath wasn't generating because it originally thought the origin point was in the wrong spot. So just switching it over in the mill part setup there allows that toolpath to generate. So going back to our presentation here, we've got these slots on the back of our part that we're going to machine with some live tooling. Now, we've got controls in the software. If if you've got a C-axis or you've got a Y-axis on the machine, or if you've got a B-axis, you've got to set the part up to basically output the correct code. And the key setting in here when we're wanting to do something with either the C-axis or the Y-axis is in the NC tab of the operations, you will see this rotary axis mode. And it says if it's either free or fixed. And this is with reference to the C-axis, so the main spindle rotating or the sub-spindle rotating. So if we output free, then we obviously get X and C moves, which will output typically a lot more code because it's trying to simulate what you're programming as say a linear move is outputting basically as a bunch of X and C moves to try and get that a perfect linear move. If you've got the ability to use that Y-axis on your machine, you can set it to fixed, and then you will get the X and Y output basically. So let's take a look at that on the part, and we'll go through and look at programming it here. So like I say, if we're talking about the difference between using fixed versus free, or X and C moves versus X and Y moves, like I said, it's on the NC tab under this rotary axis mode down here, fixed versus free. So if I set it to free, it's going to output the XC move. That's the only difference really. It's just a switch between the two. If I output fixed, it's going to output my Y moves in my code here. So pretty simple. Same thing would apply for if you're milling on the main spindle. When you're doing things like wrapped features, so if we're talking about wrap features, if we go in here and define a wrap feature for our slots around here, you'll see that it will automatically be set based on the type of feature that you're doing. So a wrap feature is by definition a free move. The C-axis is rotating, so it won't give you the option to fix it, because otherwise it would basically just not output the correct code. So to put our wrap feature in to go and machine all of these slots in here, basically we go to our stock manager, we choose our mill part setup, and we choose a part setup that makes sense to the geometry here. So in this case, I'm going to pick the top plane, and I'm going to flip it around here so that we're coming down here. So we get our mill part set up, we go and choose our wrap feature, and sometimes differentiating between these can be kind of key to how you want the feature to actually operate. Now in this case, a pocket by definition has a boundary on all sides. In this case, I've got an open segment here where it wants to actually machine past that. So I'm going to treat this as a wrapped slot. So anytime you've got some geometry where you want the tool to go off the edge because it's not a physical boundary, if it's open to the air, use one of the slot methods, a corner slot or just a regular slot, or in this case, a wrapped slot. We click on the surface to define it. We click on the end condition to define the depth of the cut here. And then we can also go through and edit the profile. And this is how we tell it whether it is an air segment or not. So in here, you've got a dark blue line, which is representing a hard physical boundary. And then on the edges over here, I can switch them to air segments. So the end edges over here, I'm going to switch them so they will actually come off of these curves on the outside here and basically smoothly come out there. So there's our wrap slot feature. We've got our operation now in here, so we'll just generate a toolpath for it to go and machine those slots in here. But you'll see when you're in the operation here, the NC tab will automatically have this grayed out because by definition the wrap feature is free. If we're doing things like engraving, so if you want to use a fourth axis or you want to engrave with the mill turn, basically the text that you're engraving with usually needs to be at the actual main axis here. So you put in a text as a sketch using just the regular sketch text option. Put it on a plane through the axis of the part. Doesn't really matter which orientation, but it has to be on the plane through the middle. And then you can basically go through and put in a new wrap feature, switch it to an engrave, and then your sketch, my sketch here is just that part number, sketch 6, select the sketch. The key thing here is because we're driving it from a sketch, we need to tell it what diameter basically to output the code at. So that's what this value, or this selection down at the bottom here is for. So I'm going to engrave it on the bottom face here, and then my end condition here is just going to be my engraved depth. So I'm just going to do, say, 30 thou, and going into the part here, so we've got some depth to it. We can change our strategy to basically choose a pre-existing strategy if we've saved anything back to our database, and then we can use our generate operation plan to kind of recall that up and basically go and generate the toolpath for that there. So, and again, because it's an engraved feature, it's a wrapped feature, it's going to have that rotary axis mode set to free. Any OD work, if you put in a mill part setup and do, I don't really have a particular example in this particular part, but if you're doing any OD work, say for instance you're cutting a slot across the face here, but you're using the non-wrap feature, you're using one of these features over here, but you're on the OD, by definition it will automatically go fixed because you're basically locking it into a certain orientation. So the main difference between the two usually comes on face features like these ones here. When you're working on the face, you get the option really to switch between the two and control the output. Going back to our presentation here, the next thing I wanted to talk about was polar coordinates, and basically getting a little bit of an understanding about how you output, what's going to happen on the posting side, and basically how the control interprets that data. So essentially, if you're not familiar with polar coordinates, essentially you're changing your output from an X and Y Cartesian kind of system to a polar system where you're using a length and an angle. So a polar system is typically used for things like a bolt PCD, where you maybe have 6 holes in a PCD and you want to specify the angle between them. And usually in different machine controls, it's either going to be either like a G12.1 or a G112 code that will come out in the code. And what you'll see is that will come out in the code, and what happens is the control will understand that and then switch all of the values and do all the kind of calculation and conversion. But I wanted to kind of just explain a little bit about what happens in the post, so you can kind of see what the difference between the two is. So I've just posted out some code basically of the contour mill operation for the C-axis, the one that we just looked at for the slots on the back of the face there. So when we're using just C-axis set to free, you'll see that we get a bunch of X and C moves in here. When we use fixed, you'll see that we're using X and Y, as I previously mentioned. But when we're using C-axis free with polar, you'll still get the X and C moves because you're using free. But you'll notice there's a difference between the values. So in C-axis free, on the green arrow, you can see the C161 is an actual angle in degrees. The C-axis fixed has a Y-axis position where it's 0.2526 in this case with the red arrow. When you look at using polar, what happens is the post will actually kind of blend the free and the fixed. It will take the values from the fixed but output the prefix of the C. So you'll see the yellow arrow, it's C.2526. So the prefix is the C-axis, but the actual value coming from the code is essentially the Y-axis value from the fixed column there. And what happens is as soon as you see that G112, which is highlighted by the blue arrow at the top there, the control triggers the switch, and it will basically do all of the calculations to convert that into a polar angle move, basically. So the post is doing the conversion from the prefix and the Y-axis movements, and the control does all the interpretation of that movement into angular movements and things like that. So essentially, that output here is, if we go back to kind of one of the operations that I was working on here, that polar is triggered, like I say, when we're set to free, and we're using polar or cylindrical. So if we're on the OD, typically you'll see cylindrical coordinates. I believe it's a GO7 or something like that, to call the cylindrical coordinates out. But when on the face, typically we're going to be doing polar, and this will output that G112 in the code. So this is the switch basically to output the polar coordinates into the code there. So moving on to sub-spindle transfers. Basically what we can do in CAMWorks is we can do all of the programming of the transfer exactly how we want it to operate using the sub-spindle operation. And it's basically a graphical interface to define each of the stages that you want to happen during that transfer. For example, rapid the sub over towards the main spindle, feed it in towards the part, clamp down, unclamp the main spindle, retract back to the home position, and so on and so forth. Now there's a variety of different transfers. You might be using things like phase synchronization if you've got a hex on the part and you need to kind of orient the spindles so that you can actually clamp down on a flat on the hex. You might be using some of the speed synchronization to synchronize the spindles together to keep the main and the sub turning if you're using it almost like a tailstock and kind of, or a steady rest, to keep the support going and synchronizing the spindles so that they're all operating at the same RPM. Or you can just do standard transfers. You can just do grab it, take it home, or you can do things like grab the part, pull it out a small distance, do a cutoff, and then take it home if you've got like a bar feed or something like that in there. So we're going to go through a couple of examples of looking at sub-spindle transfers, how to set them up, what options that you have to control the output, and things like that. So like I said, in here, we've got this part, we've got our main spindle and our sub-spindle, but at the moment, we don't have any transfer. At the moment, it's just on a cutoff. The part is actually just dropped into the bottom of the machine, and we're all wondering what's going on. So what we have to do is basically put in the sub-spindle operation, and that's done through a right-click and choose the sub-spindle operation from the menu there. And we can use different templates. If you find that you're using lots of similar transfers between the main and the sub, if you're using kind of maybe 2 or 3 common transfers that you do on a day-to-day basis, you can program them in here and save them back as a template, and they will come in this list. So if I'm just doing just a take it, grab it, take it home, I can do a standard transfer, and it will give you details down here. Standard transfer to take the part to the sub-spindle home position. So it comes across, grabs it, basically takes it home. And what will happen is it loads up this sub-spindle parameters dialog here, and you'll get a series of stages. So you'll see I've got my sub-spindle over here. It's currently turning off my main spindle, turning off the sub-spindle, so nothing is rotating at the time. Orient the spindles, so I can do spindle orients, and then it rapids the sub-spindle over. And I'm just clicking through the steps, and the graphics are actually updating on the screen with where it's actually rapiding to. So if I wanted it to rapid off a little bit further off the part, so it's not just feeding all the way onto it, I can do that. Feed down to a position to clamp onto, so we'll just adjust the clamping position maybe to here. And then the sub clamps down, and you can see the jaws clamping down here. There's a dwell to let the pressure build up. Then the main spindle unclamps. We let the pressure relieve, and then we basically send it to the home position. So that's just an example of a simple transfer. It goes in down here. Basically, what we can do is, well, in this case here, we probably want it to be actually no, it would want to be down there. We'd do the cutoff. We probably wouldn't do the cutoff at this point, but the sub-spindle transfer would come over, do the cutoff, and then it would go home. But say, for instance, we want to be a bit more complex. We want to do something like grab the pot, pull it a distance, do the cutoff, and then take it to the home position. Well, what we can do is we can just delete that one out here, and we can put in our new sub-spindle operation. In this case, I want to grab it and pull it by a certain distance. So this one is a predefined template in here. Again, it does the main off, the sub off, orients the spindles here, rapids to the home position, or basically a distance off the home position, feeds down onto the pot here, clamps, unclamps the main, pulls at a certain distance here, and then it clamps back on the pot. Lets the pressure build up, and then in this case we've got some speed synchronization, but we could do phase synchronization in here as well. And we set the RPMs and so on and so forth. So we've grabbed it, pulled it out a certain distance. This one in this case does want to be before the cutoff, because we're basically going to pull it out and then do the cutoff, and then we're going to take it to the home position afterwards. When we're doing that, we need a second transfer that basically says, once you've finished the cutoff, take it to the home position. So turn off the spindles, basically send the sub-spindle home. And that would come after our cutoff has happened. But in this case, because we grabbed it and pulled it at a certain distance, what we need to do is actually shift the position by that distance. Basically, we need a new turn setup in this case. So in here, I'm just going to right-click on my turn setup. In this case, we're on the main spindle still whilst the cutoff is occurring. So I'm going to put in my turn setup here. And this is so that my cutoff is occurring at the right spot. So in this case, because we've pulled it out by a certain distance, in here, we've pulled it out. Sorry, that was the wrong one. I've accidentally moved these around to the wrong direction. So we'll go here. Because we've pulled it by a certain distance here, say for instance where is it? Here. Yeah. So if we go say 2 inches or something like that, basically what we haven't changed the physical G54 on the machine. We're still working at the G54 home position, but we've pulled the pot away from it. So what we can do in this cutoff here is we can shift it along the axis to say that the coordinate position is shifted basically a distance here. So in reality, sorry, that was -2 inches here, because this is basically the physical home position on my machine, but I actually just pulled it out by those 2 inches, so it's actually shifted position. So the cutoff is now going to occur at this position, and then it takes it home. So the sub-spindle transfers can be customized to exactly what you want to do. There are different stages in here as well, so you can customize these. You can delete all of the stages out and go through and say, add your own stages in here. So if you're doing a rapid move or feed move, or if you need to lock the spindles, or if you need to orient the spindles to, say, rotate the spindle 20 degrees, 30 degrees to clamp on a hex or something like that, you'd use a spindle orient. Set the spindle speed or do the synchronization between the spindles. If you don't see a field in here, but you need a code out, so typically these stages are involving some sort of movement or motion on the machine. But if you need a certain M code that's called out, or I don't know, you need to switch it to some sort of mode on the control, or you just want to put in some comments, basically you can use the text field. If you leave it set to output as comment, I usually put in things like a start transfer here, and then I just drag this up to the top here. So you just grab it, move it up, and then grab it and move it up, basically to wherever you want it in the program. So if you output it as a comment, then you'll get the parentheses or the semicolon or MSG, whatever your control needs. But if you actually put in a text field and uncheck, I can output, say, an M203 or an M210 or whatever basically in here, and this will output direct to the code minus the parentheses, so we'll be actually using my M codes and so on and so forth. So, and when I post out that, I would get the those M codes and additional parameters and things like that I need. So with that, that's the end of the kind of principal content. I hope you learned a few things from this. I hope you like seeing the new interface. I really like the updates that CAMWorks have done. They've made a great job of making it a lot easier for us to select origin points and things like that. If you're interested in any of the up and coming webinars, one of the ones I'm looking forward to in particular is the one on January 31st there, powering up the motorsports industry with SOLIDWORKS flow simulation, looking at air intake analysis, I believe, in internal combustion engines. I'm going to sit in on that one for sure. But check out our up and coming webinars. These are all posted to our Hawkridge website under the events page. And if you guys are attending SOLIDWORKS World, then we'll see you there. There's a few of us in the CAM team that are actually presenting at SOLIDWORKS World, doing a variety of different things, talking about SOLIDWORKS CAM. I'm doing a presentation on post processors and using the universal post generators. So if you're coming down to Los Angeles in February, then we'll see you there. And if not, well, let us know how things are going and contact us through support if you've got any questions. Thank you very much for attending. Have a great day.